Yeah, like I said, I'm excited to share my findings around like the auto scaling this evening. I'm sure most of us would have watched like at least P95 latency triple when the CPU dashboard sat at like 25%, right? And the autoscaler did like absolutely nothing. And that was a real example that I went through in the organization at scale. So I wanted to set a stage for like next 30 minutes. So I'm definitely going to argue that that threshold autoscaling is structurally late, but not like badly tuned or anything. I'll show like how or what we replaced it with a learned scaler that predicts the load and acts early, and how we measured it. And I'd also end with like, okay, we don't want to say like where it is all like perfect, because that also fails, right? So I wanted to also walk through like where it fails, so that like we don't want to take this in a production capacity. So like I said, this architecture and the framework that comes out of one of my published research work. It has like multiple pillars, but today I'm just focusing on the auto scaling one, plus the guardrails that made it safe to run. Yeah, I think we went through this, so I'll skip the slide. Yeah, picking up on my own real incident, like I said, I worked at a production environment where we had like frequent launches, both planned and unplanned. So when I say like a planned one, what it means is like a Saturday morning at 7, we used to have like these launches. So at 6:59, your traffic is like, okay, gradually increasing. But at 7, there is a peak. So that time, what happens is like the traffic definitely rises. The latencies, it went vertical. CPUs would stay low, but the auto scaling, it was like it was picking up. We were doing AWS auto scaling. It was picking up, but then like for the most part, like the humans, mostly SREs, eventually we would have to come and scale it by hand. But this is definitely not a tuning failure, right? Like nobody set that threshold at 70% when it should be like 45% or so. So if your autoscaler is actually watching the wrong number, no amount of tuning would fix it. So you need to like watch more numbers, and again like to watch them earlier. I think that is a big scale what I started to look in.
Memory utilization, because it does CPU utilization and this auto scaling on the memory utilization. That doesn't work either.
No, it did not work either, because like I said, like at 6:59 you might have like 300K or so. At like 7 o'clock it would be it might even go to like a million or 2 billion requests. So that is like a real peak rather than like gradually getting that number of requests.
Question. I was just looking into what the P95 is or whatnot, and it was saying that's like like just a little bit of it is taking a long time. So can you give me sort of an example? Like you said, the 7 o'clock peak hits. I would generally expect stuff to like kind of uniformly slow down because a lot of problems are happening. Does this mean only some of the nodes are performing poorly?
Yes. So it is not that. So during even with that setup, like what happens is like we never used to have that website is down or anything.
Right.
Just that few users would have a bad experience. So even if we have these launches set up and like say if there are like 100,000 products to be sold out and whatnot, it sells out in like 5 minutes. But then like the experience for the users was not at its great for some of the, exactly, not everybody would hit. That is why that P95 it would come in. So yeah, this is the conceptual core of the first act, right? In a generic case, it is a pod that is technically alive. Yeah, passing this liveliness probe, consuming like very little CPU because it stopped in a collection and served like nothing. During the warm up, this is like one people really underestimated. If there is a JVM pod that needs like 20 to 30 seconds before it serves at a full speed, then a reactive scaler that adds at that moment of that peak demand So that adds a liability, but not a capacity. So that is why I think the oscillation is like really expensive one. On the GPU, again, from our research, during these spikes, the CPU had like sat at 20 to 30%, whereas like our GPU utilization was like at 95 to 100%. The HPA had like no visibility into either of this. So, and on the downstreams, like again, what 20 seconds or something, like sometimes the correct auto scaling action is not just by adding the pods, because the constraint could be like even further downstream, like it is a database connection limit. Then like if you're just thinking like auto scaling is only about like adding the pods, you're about to convert that slow service into an outage also probably. So yeah, I think the first problem is that like looking at the wrong things, and the second problem is like looking it too late. I think that's what like it was a realization. So again, like the autonomy of scale up that arrives too late, like I wanted to walk through the timeline from left to right, because like at 7, that is where like the demand arrives. The queue begins to like grow at T0. Every second from here is like latency where you are like already serving to the customers. 7.1, you cannot act on at that instant. So the monitoring tools, like it takes some time for it all to be like average out and whatnot. Like that short window makes it like really long, like makes it jittery, whereas the longer windows making it like very slow. At 7.2, the threshold actually crosses and the decision happens. So if you have like configured a stabilization window to stop flapping, and like here also the threshold would have already crossed. At 7.3, the Kubernetes would have found a node, possibly pull in an image, start a container, and that would make like even more worse in that 1 minute. So by 7.5, the pod is ready, but then like not very useful. It is because like I think given that scale and the volume of requests that used to come in on that production system was like really at a peak. It is not a gradual increase, but a peak. So here it is like none of these steps are like, or none of the things are like it is a defect or like it is an incorrect one. It is because like it is the behavior of that built reactive system. I think that was a bigger one, right? Like which means we are just removing the lag, but then like we are still being very reactive to it.
So place where I joined, so they had microservices running in Kubernetes and Python.
Mm-hmm.
And they consciously made a decision not to use Java because of this JVM warm-up time. So that's why they use Golang. Golang doesn't have a warm-up time.
Ah, okay.
So that 20 to 30 seconds,
Mm-hmm.
it's like, it's unacceptable because when it starts speaking, even if you start all the pods, it will still take a while for the JVM to start up. Even the logging thing has its own startup time. All of the Java stuff, the JIT compiler will work after everything starts up properly. But that startup time is way too long.
Exactly. Okay.
That's why everything is moved into Golang.
Golang. Okay. Oh, good to know.
On Kubernetes.
I got a question. Vaguely familiar with Kubernetes. Isn't there like a startup time with that as well? I've not done AWS.
They have a readiness probe and they have some other probe. They have 2 probes and you can keep hitting that, but the whole problem is the JVM startup time.
So you can go from 0 to go this pod on Golang, being ready within 5 seconds, or is the spin up of a Kubernetes in general, like that's another 30 seconds?
So Golang, what happens is when you compile it,
Yeah,
you can compile it, the same program
sure,
can be compiled into binaries for multiple operating systems, direct binaries.
sure.
Right? And it has all the libraries and everything built into the binary build.
Right, sure.
Right. So now it's a native.
Right, I guess what I'm asking is, if you were mentioning the 20-second warm up, in reality, like, is it more than that? The container takes another 30 seconds in front of it to kind of come up one of these nodes when you're spinning a pod up, or is it like, so like, are you realistically literally looking at 20 seconds, or is it like a minute and a half to get responsive.
Yeah, it is definitely more than that 20 to 30 seconds because like this is only the pod startup.
Right.
Exactly. Because like the JVM, like I said, like that has a even more
Yes.
time to add to it. So with JVM and the Kubernetes, the combination, I think like it is still a problem because like especially with like the amount of volume that we wanted to have that auto scale, like that time really matters.
But
Mhm.
if you're saying like a 5 minute window, and it's like, do you have any numbers that you know off the top of your head that like, a pod from 0 to Java starting 20 seconds, 3 minutes, 10 seconds?
I do not have that because like this is not a thing that is tried and tested on a production environment where like it is more like I said, this is the problem is from a production environment, but
Yeah.
then the solution that we put together is like not tested on a production environment, but more on the research side of things.
I could make the case that switching to Golang, whereas Golang may be good for that purpose, switching from Java to that shouldn't, because of the warm-up time, shouldn't be a reason to.
That's
No.
one of the reasons. I mean,
Yeah.
it's way faster because for Python, availability was here, and with Golang, it jumped here,
Yeah,
essentially.
yeah.
That was the reason they did it. I wasn't the decision.
Yeah.
maker. I was like, I just went along.
Yeah, I understand. I guess what I'm the point she's trying to make is, it's not about 10 seconds to 20 seconds.
Yeah,
to-
I agree.
None of that matters
Yeah.
if you know your system.
Mhm.
I agree. I agree with the basic, premise.
Yeah.
I'm just saying that in case,
Yeah, okay, so if you have a multi-tier, system. right,
Application.
when the users come, all they see is their browsing. And browsing traffic is just like you load an MC,
Mm-hmm.
right? That is one thing. So until they are entering a payment system and picking up product, or, you are not hitting any of the backend stuff.
yeah.
Sure.
So at this point, it's not a matter of, 2 seconds before or whatever.
I
right?
agree.
You should-
I mean, I agree with the
you should
basic premise.
Well,
Yeah.
Yeah, I'm not trying to,
Yeah.
so you should know your system entirely,
Exactly.
right?
Yeah.
So that you know how it behaves when the rubber meets the road, right? Because sometimes you just click one thing on the UI and then 50 other things happen in the backend. So what are those 50 things?
Yeah, in addition to knowing the system, the entire system, I think it is also the user actions, right? Like again, definitely a search is totally different from like adding to cart or like making to the payment or like I'm just doing order retrieval and whatnot, right? I think the totality of that system plus also the user interaction, I think it plays a role.
This was just a suggestion if you're using Java. Like one solution is people have gone towards Golang.
Mhm.
The other solution is there is a VM, Java JVM called Graal, GRAAL.
Oh, okay.
And that's a native build on your OS itself. So it is a JVM.
Mhm.
So your Java program will run as it is. And it's called Graal.
Okay.
Yeah,
So
we
it's-
did Ground, we did Ground, that's a pre-compiled Java, right?
Yes.
To the
Oh.
specification,
Yeah.
So you can do that, even if you don't do that, right?
Yeah, that's still a problem.
P95 is P95. What is 94?
Yeah.
Yeah.
How long does it take 94 to 95?
Mhm.
What about 93,
Yeah.
right? So,
Yeah.
I'm sorry, when you do this particular thing you're talking about, the Graal or whatnot, you still have all the thread pulls and connection pulls all have to come up, even though you're getting some native like optimization, obviously.
yeah,
Right.
you're using lambdas
But
or
you're,
whatever.
you're skipping bytecode, but your startup is not free. Gotcha.
Yeah.
Right. Okay.
Some hardware will have one up somewhere, something will go to some load balancer somewhere, so just
Okay.
best thing, just know your system, know how you
Yeah.
react, what is available to you,
Okay.
and be smart and get ahead of it.
Okay.
And
Or
there's-
use some AI that knows how to get ahead of it.
Yeah.
for us.
And there's additional issues like, so you have nodes in which pods are running. So if you have, like, say, 8 pods
Yeah.
running on 2 nodes, right?
Yeah.
So there's 4 per node, and
Right.
that's like at capacity.
Yeah.
Now, if you want another like 20 pods, first it has to start up the nodes.
Yeah.
So there's the node startup time, then there's the pod startup time,
Right.
and then everything else,
Right.
right? So you would have to keep all these extra nodes running which is basically it's money, essentially, right? You will have to keep like, so if you know, okay, I'm going to have 20 VMs coming up, like 20 pods I need. So you would have to keep 5 more nodes up and running,
Gotcha, okay,
right? Which costs money.
right,
I mean,
yeah, right,
Yeah,
right,
I
right.
mean, for Nike, it doesn't matter. I mean, they have money, but for a small startup, all those things like just
Right.
add up like the cost.
Quick, right, okay, okay.
Yeah, I think definitely the cost factor is like a critical piece. It is just not about like, oh, you wanted to run your system at scale and whatnot,
Yeah.
but then like you are spending like tons of money on the cost. Like again, it is not really proportionate with like the solution, yeah, that you're building. So I think we definitely have to like balance that out. And I think it's a critical piece. And especially given the current situation, I think like that cost plays even more a priority or like maybe takes that top seat, I believe. Where like, hey, because every organization now is like, oh, where can we save? Where can we save? Right. So yeah, that's a critical piece right now. Mhm. I think what we did here is like the threshold scaling. I think again we split into like 3 different space, like a reactive lag. Again, I'm not going to like re-explain that lag or that mismatch, but again, I wanted to spend more of my time on the symptoms, where like so that it is easier to connect the dots on where the problems are. And then the oscillation, I think that is the one that gets like the least attention and cost the most quietly, like I said before, right? So I'll cover that and also the metric mismatch. I think these 3 things are like not independent issues or a problem that is fixed all at one time. So they're all like downstream of that same design decision, right? A fixed rule of reacting to a single lagging indicator. I think that is why our approach, that I think at least what we came up with was like a decision procedure rather than just adding like more rules on top, adding one over the other. Yes, so on the oscillation part itself, I think again, this numbers are from our evaluation only. The rule-based baseline, it produced like at least 15 scaling cycles per hour on like a fraud detection. And again, like I think that was produced on like a scaler that produced like 3. So the mechanism that we used is like consider we have a system with like a delay and like we have a controller so that like it rings. So but then like adding pods aggressively, that utilization per pod definitely collapses. I think whatever Nitish mentioned, right? Look, we have the nodes and then like we have the pods. That scale down rule also fires where like you have to reconcentrate on like fewer pods, the threshold crosses again and what. So nothing about the traffic would have like actually changed, but our the systems the utilization or the pods, I think those are like the driving factors. And again, why it is most important is like I'm sure we all would have gone through that stabilization Windows configuration, right? Like, and it definitely, I think it helps. So by making that controller slower, so we move along like a trade-off curve, but not getting totally out of it because it is a launch day, it is a problem, and like it is not only about the revenue, but also a best user experience. So the reactive scaling over provisioning and like still runs late, right? So at least on our the real-time scenario that we used on our production system, again, nothing to do with Kubernetes in there, but on reality, what used to happen is like we were on AWS and like we had that auto scaling, but then we very quickly realized that auto scaling would not help that peak traffic. So what we generally used to do is like we scale it up the previous day, like the Friday evening, we scale it up, keep it up and running till like the Saturday morning for launches to be happening successful. And then like I don't think most of the teams really go scaling down after the launch because like, oh, it's a weekend. Why do we want to sit in the front of a computer? Let it stay there. And Monday morning we come back and like scale it down. That was the real, like it was more of a reactive thing. That is because, again, we do have like surprise launches also, where like we were not able to get into that because like we would not even know that there are like shock drops where we are not able to be that reactive as well. This scaling or the over provisions, I think from our experiment, on the left, if you see, the baselines had like at least 7 to 8 pods. Again, traffic was only at like 20% of peak, which is roughly like 60% it goes weight. Because I think it is still that same conservatism where like it makes like overnight provision and so that like we don't want to put that launch in a risk. So that's exactly the thing like we tried out here also. On the right, if we look at it, again, from our architecture, I think we try to pick in like three different things. One is the performance, the cost, and the security or the compliance. So the resolution here is like, oh, whoever would have escalated the loud like the previous quarter, that they would be winning, right? So our argument is more partly like the autoscaler does not know the budget. That would definitely not know the budget. The policy engine, that would not know the SLOs or the latencies. Or the cost tooling, like that comes in like an after effect, right? Like only on a monthly basis we do. So there are like three different rules, three different owners, but then like there is like no shared objective. So if the problem is like just ruling the reacting late to like one metric, I think the fix is not a better threshold. So then on that production scale itself, like we moved from a reactive autoscaling into predictive autoscaling. Again, these are, or this was an architecture where like, okay, now it was still with an EC2 AWS architecture. So what it generally does is like the teams which owns those services, which would participate in those launches, they would upfront know that what is going to be the traffic for or predictive traffic for those launches. A launch could be like 3 million per second, or like, again, they give like what could be the traffic, what could be the number of items that is participating in these launches and whatnot. So what this architecture made is like, it, because it is predictive, so it keeps checking like, is there an active launch, is there an active launch. Like what it does is like, oh, if there is a launch in like 30 minutes, there was a scheduler job, so it runs every 30 minutes, or like I think it is on a schedule basis. So it runs and say like, oh, if there is a launch, then like I wanted to go keep these services scaled up right before the launch, and then like after 30 minutes, so after the launch is all done, it brings it down, like it scales it down. So this was still a predictive auto scaling. This worked definitely better than how it used to be, because like one, on the cost, where like you are not over provisioning it all the time, and launches happen very frequently, and during the holidays it is even more. Like not every Friday is the same, and not every holiday is the same. So this definitely worked a lot more better, but still where it was like trying to fade out was more around like shock drops. Not every time you would know that, hey, there's a launch that is coming in, that is planned and whatnot, right? And that is the beauty of Nike as well, where like you have these so this predictive auto scaling architecture also was not working perfectly fine for those surprise launches and things. I split that into like 4 different parts. So this one is like scaling as a prediction problem. Yeah, so taking that launch morning example itself, because like it is the traffic has a structure, right? It could be a daily cycle, it could be weekly cycle, or like a marketing campaign, or like a bad job. It could come in like different fashions, right? So the threshold scaler, that would treat in like every one of this as a surprise forever. So it has like no memory. So everything is a predictive launch, or like a predictive scaling that we wanted to do. So the 40% over 5 minutes example is from our experiment that we did. So that is the kind of trend that we learned from the policy that picked up on and like acts on the trend rather than like one particular problem only. So the forecasting load is a solved-ish problem because like, yes, now it is not treated as like every Friday is the same or like every Monday is the same. Rather like we do like, okay, what was it last month? What was it 2 months back? What was it last year? During this holiday, how was it? So that predictive thing and like everything was treated and the forecasting was like a pretty good one. Whereas the hard part was not only the forecasting, but also choosing like which action that we can like completely trust on, right? Which is why the objective has like including the cost, because like I said, it is not only about the experience, it is a combination of your user experience, the cost, and the scalability. So then we moved on to like experimenting. Do we really need that reinforcement learning? So when we take that option one of like smarter signals, I think most rooms would have like exhausted this, right? Like scaling on queue depth or the GPU utilization, where like using the custom metric or like external metrics, like a configuration change, like not treated as like a project, but then like it would fix that failure mode. So this is a very like minimum to get this around. Then the second option is like forecasting and the formula for the load with like strong daily or the weekly periodicity. So what we did is like, which is the business traffic, the forecaster plus a capacity model that's get you most of the predictive win, right? So I think that, and it is definitely like an auditable. So what we did is like, we try to like do like on like multiple published systems live and then like see what is that phpa reported, and again like that 20% throughput gain. And there are like multiple experiments already there, like the graph phpa was one, and like I think the pro scale that also targets like the proactive edge workloads, and then the learned policies. So it adds in not like a better prediction, but this is more like, oh, contain more than one thing. It could be the latency, it could be your dollar amount, or it could be the churn, or all in like one. So I think this is the actual argument of it, right? Like we built option three, and I'll show you how the numbers looked like. But again, I'm not saying only the option three is right. Even if we know that if we get that option one or two, that is like most of the teams would be able to like surface with the option one or two itself. And oh yeah, scaling as a decision process, right? Like, yeah, if we look at it here, so we have like three different things. One is the state, one is the action, and the reward. So looking at the state, I think it is the important observation here, because that state is the vector that would contain that signals HPA that would not be able to see, or the GPU utilization, the memory, the queue depth, latency. So it has like multiple parts to it. Then we have the action. So I wanted to emphasize on how small that action space is, because it could be like one or two parts per decision. So that is again like depends on how big is your system, what is design choice about the blast radius, and all of that comes into place. And then the reward that has like three things, like the SLO violation, dollars, and churn. I think these are like the important metrics everybody cares about, right? I think like as I mentioned about like not everybody is like, oh, if we are better on cost, like if it degrades on the user experience, no, it is not a better experience. If the user experience is best, but then the cost is really high, again, that doesn't really go well. So all of these have to like come hand in hand, and that is why we wanted to see like, hey, how we can like classify these ones. Yeah, I think the state vector here, I think the most immediate action was like I'm sure like on the left I could see like what we fed into it, right? Like I showed two things that is worth there. One is the RPS, like the request per second, plus its trend. not every time the request is the same, because the derivative is like what makes that early action possible. Then second, the time of the day and the day of the week, right? Like I said, Monday of this week and this month is not the same as Monday of next week or the previous week or the previous year. So I think those are like probably the important things to be calling out, and like it is worth calling out. And then splitting that latency into the queuing versus the service time matters. So this is where like I think that queuing growth means, where like, oh, you can add like queuing growth is adding pods, whereas the service time grow means like a pod is sick, or like a pod is degrading, or like the downstream system is slow. So again, like I said before, adding more pods is going to make it more worse rather than like making it helpful to us. And on the right, I put in like, okay, the JVM specific part, the memory used is not like a signal. So the live heap after that collection is like or if there is a garbage collection pass fraction, like that could be like a best proxy for the pod that is alive or like cheap on CPU. And that's exactly the case that I mentioned in the opening. Yes, so the reward function, I think this is what I mentioned, where like, oh, the technical content of that reinforcement learning, like where the auto scaling is like a governance content, right? Like it is not only about like, oh, we do all of this, but then like without a governance, I think we are going to fail. So I think every organization already has that implicit value of like the latency, cost, and the oscillation. So in our runs, what we did is like the oscillation penalty is what like we took the cycles from 15 per hour to 3 hours. So without that, the policy is like happy to flip, because like each individual flip would barely like register against like latency or the cost. So that is why like the more importance is on the oscillation. And the second one, the cost, is the real operational warning, right? Like I said, the change to the beta, again, like it could be like without no deployments, or like without there is like no repository changes or anything like that. Again, that reward definitely weighs in the version control or like the active logs and whatnot. So all of that turns it back to our scaling decision. The training part was like, okay, how did we get our models to train and see like what could be the outcome? Like we split that into like 4 different offline training. So one is like collecting, especially this was important because like if there is a brand new service, we would not have those existing logs already available. So, or like if it was like a re-architected service or anything with like a traffic pattern has changed or whatnot, right? I think that's why like we wanted to collect as much as data as possible. And then we go on like training model. So that is like again for our evaluation, what we did is like about 500 lines of Python code with a deep queue network. So the hard work was more about like feeding in the data and like the guardrails, but not the model itself. So I think anybody could write that code, but then the question is like whether they should own it or like if the guardrails are put in place. Then the shadow part, again, that was like a couple of weeks where we were able to see like the HPA stays in charge, or like you get like a free evaluation set and whatnot. And then the exploration in the production, right? Again, this we try to have like an open source because it was not tried and tested on a production system. Like we have we ran it against one of the open source. And again, like so that way, like it gives us like more preempt to it, right? Like again, 10% on a production system, I think it is still okay to say, and like it's comparatively very small number, but the actual results could actually vary if we run on a really large scale infrastructure. Yeah, the control loop here. So we started with like, again, This is an ordinary controller, same replica field that HPA writes to. So again, it starts with like a telemetry, your state builder, learned policy, policy gate, and the Kubernetes API, and it all goes in a cycle, right? I think that is how like we started to like put in this framework together. Then comes the second part of like the guardrails, the fallbacks, and like what we learned from it. Um, so yes, these are like four straight from the framework itself. One is like the minimum 2 replicas, maximum bounded by the namespace quotas, plus or minus like 5 minutes per or 5 pods per minutes, and then like the cost. So we took into account all of these, and the important architectural point on these would live outside of the model. So the model is not going to feed these ones, but then the architecture turns outside of it. So they're not the.
So tells you I want 19 extra pods, your harness around it just says no, only 5.
Exactly.
Okay.
Yep.
Okay.
So what we spent on is like the time more on the bottom line rather than like spending more on the models itself, so that like we get like closer or like realistic numbers, so that like we are not doing like over provisioning or like under provisioning, or like that autoscale itself becomes like an overhead. Yeah, again, decide in advance on what requires a human, right? Again, so this was more like, hey, when do we wanted a human in loop? Again, with I don't think like human cannot be in the loop at any point in time, right? So but then what actually matters? So on the right, like we put up a mocked up Slack message where like, oh, most of the approval workflows fail because not because the gate is wrong, but because the message is like not useful, right? So if the autoscaler wanted to come in and like change applicas, like would you approve or not? Again, at a 3 a.m., do we really wanted this one in loop? So the timing also matters, and like the exact message is an important one, so that like the human in loop would come in and like make the informed decisions rather than like, oh, doing it on a random basis. Yes, so the fallback, again, so there are like 3 things. One is the controller crashes or the wedges confidence below the threshold, or the LLM's timeout. So there were like 3 degradation paths, all from the framework itself. The controller failover was around like 80% of CPU, but down at like 20. So it is a 80-20 rule. Whereas the confidence under like 80%, that escalates, or the LLM would time out back on the raw JSON. So our reason why we wanted to keep that fallback is as much as technical. So you could actually ask me like, hey, what happens when your model breaks, right? So answer is like, we go back to exactly what you're running today. So that way, like it is not like, oh, we are going to rebuild, or like we're going with a second model. Rather, you're like double, if you're going with a new model, or like if you're going with a second model, like you're going to double up the problems more rather than like saving what you already have. So the general principle here is that explainer, I think that must never be like load bearing for the control decision. So that LLM timeout becomes a scaling outage on a whole. Yeah, I think why this framework actually worked, and what it proved as is like it tracks what changed. When the casual reasons with like numbers, or the cost consequences, or like it did pass that policy gate. So there are like 3 uses. One is like debugging. Whenever the scaler makes a bad call, it needs to like, oh, it is just not to not termed in as a behavior, rather like, oh, you have to believe in it. Then the audit part, where like the finance or the cost comes into play. And again, like I think our policy pass rate went from like 68 to 91%. And then the trust, I think this one is more a real one where like, oh, you should have that human in loop where like it makes a lot more human supervising. I think it acts way more faster than like we actually watch in. And what we measured. So, oh, sure. Uh-huh. Yeah, we used the clusters here again on the Kubernetes 1.28, 10 GPU nodes, like 800s. Again, not a production scale, but still like the ones that we could experiment and come up with like at least approvable numbers. Yes, so this one, like latency and the cost, I think it looks like the opposite, only if the controller is choosing like a single level, right? If it is the scaling up after the breach or like refusing to scale down after an hour, then like it is simultaneously going to slow and also like it is going to waste your resources. The throughput number is worth looking at it because like it is not that parts that goes faster, but it is that they stopped being like overkilled or like or restarted all the time. So that each scale down that cost like 20 to 30 seconds of that disrupted connections, and that warming down or like going from that 15 cycles of an hour to 3 gives that time back. So I think as much as auto scaling is about like scaling up, but scaling down is equally important as well. Then our MTTR, MTTD, and the policy rate. So that is something that we put up like numbers so that like this framework cannot bring in that actual numbers, but from the autoscaler itself. Yes. So, and I think in my previous slide, like there was that 28 milliseconds, right? So I wanted to dig deeper to say like where that 28 milliseconds came from. So I said like we were doing the queuing mechanism. So the queuing actually dropped from that 40 milliseconds to the 12 milliseconds. So this is a predictive effect there. Almost by what happens is that when the demand arrives before the capacity, that 28 of that improvements actually stays within that HPA itself. And then the service time that dropped from like 80 milliseconds to 68 milliseconds, that is from the GPU, the effective batch size, and like how the request distributed across pods. It is not like everything on the single pod, but then like on the replicas, how did it do? Again, nothing about the model or the hardware changed, but same code, same A100s. The only difference is when the pods appeared and like how they are like scaled up. So that is how I think the capacity decision arrived at these numbers. Yes, so this one we did not really do a build a better learner, rather like again these are the ones which are like already existing, like nothing new, like the PB scaler or the graph PHPA. Again, these are like published ranges, so we wanted to do that like with a comparison, how could this model work. And yeah. Oh, sure.
These are other products.
Yes, already existing mechanism that is already available, and like which we took as a baseline when we were designing our framework, so that like we can have a baseline so that like we can do a comparison study.
And how did it look compared to the same?
Like I said, this was not tested on an actual production system, so it becomes like a challenging one for us to like compare with like already tested and have that baseline. So we did not really, we wanted to study what exists and also see like how it behaved and compared with our framework, how it would look. But the actual numbers itself, I think it would be worthwhile to see like if we could put it on a production system.
Well, then you might not be able to answer my next question because I see two factors here. One is you're using AI to generate the formula, that Q formula you described, but you're also tying in factors that typical autoscalers haven't before.
True. Mhm.
and you're seeing an improvement. My question is, can you divide that improvement and say which one is the cause for each part of the improvement?
Yeah, I think that like I said, like because this was not set up on a production environment, because this was more like on a open source, then like it was just like, oh, you injecting, or like more of a chaos engineering, where like you are injecting that traffic to see like how it works. So I think that real numbers would be worthwhile testing it on a production system. Yeah, like again, as I mentioned before, like I also wanted, so like I said, everything is not just perfect, right? Like we wanted to also put in like the painful parts to it. So first thing first is like lead with the numbers. So we went with that 30 days. So in our work, the DQN was like trained for like 30 days on like the offline traces, new services, new if new traffic patterns, and like it has its own limitation, but it is not a true one. It is not an implementation detail. The consequences here, the services that most needed that help was probably the newest one, because like we injected, it is the our own built service and all that, right? So those are exactly the ones, like you mentioned, like yeah, that was something that we were not able to get. That how can I compare with the baseline other autoscalers with ours, because it is not a production implemented. It is a production ready architecture, but not a production implemented on a production to see the actual results itself. And again, I think I covered on the new services. Then yeah, the retaining point, I think that definitely requires more emphasis on it, because like that recurring cost, um, that is something that most of the times get forgotten about in the budget and all that, right? So anything that changes the relationship between that load and the capacity, that invalidates the policy. I think that's where like I think we struggled a little bit. And then finally on the version also, where like pin the policy, log which version made each decision, keep the previous one loadable. Again, model rollback is a capability, but then like you wanted to do when do you want it to do. So that those are like real pain points that we had. And yeah, I think yeah, this is exactly what I said. Like, oh, the first time it meets the Black Friday, I'm sure it would fail, because not every Fridays is the same. And yeah, I think that is a known fact, and like we have to agree on it and say like, hey, every system is not just perfect. I'm sure we would have like failures, learn from it, train it, and like go back. I think that loop has to like continue.
Yeah, I would say past behavior is our best indicator of future behavior. It's not a good indicator.
Exactly.
It's the best one we have. Is there any other indicators though that we could somehow harvest and feed into this?
Of course, like historical data for sure. Like
Still past.
yes, it is still the past. Yeah, I think that was at least the way that we used to always think. Like, oh, how was it in the last Black Friday? How was it during the Cyber Monday last year, right? So that's what it is. And like yes, we of course do like, oh, it is not going to be the same as how it was in the past. But at the same time, I think that also comes with a pain point of like, I don't know how it is going to be in like real Black Friday day. So I think that's where like we have to like really agree upon that that pain point is real. And like that's where the system and the cost, or like your scalability, everything comes hand in hand, I guess.
How is the level, how does it like send a message? Is it leveraging the HPA internally inside the cluster? So it's sending a message to the HPA?
Yes.
So how is it sending a message to the HPA? Through the API?
Yeah, through the API. Yep.
But the API is now in EKS, right?
Mhm.
AWS EKS in the cloud.
Right.
So, but in EKS, you have access only to data plane. Right? And so how is this thing? So it's where is this program running, which is sending a message to the HPA?
Oh, okay. So we did spin up our own AWS EKS, and like where we put in our API there. And then like we have our Kubernetes cluster where like, oh, we send this message so that like we connect these systems and like send the load. And like I said, we perform like the chaos engineering where like we artificially publish or like send requests to that API and see like how is our cluster behaving during that load.
Question. You keep mentioning like upscaling by 5 pods, 10 pods. Can you disclose sort of what the scale of this, the regular number of pods was? Is this a thing of thousands of pods or tens of pods? It was actually the baseline which you're always running with. What was sort of the scale difference between what you're allowing it to choose and what like HPA is ordinarily? Is it regularly telling you it wants to go 50 pods higher and whatnot, and you're just clamping it down to it can only choose your system can only choose 5, or is that like sort of a realistic thing that you had humans in the loop to be like, I want to approve 2 of them?
Mhm.
So yeah, what's kind of the scale there?
Yes. So what we try to do is like, again, yes, HPA does have like the recommendations to say like, hey, based on this traffic or like based on this scale, like we have the X number of pods,
Yeah.
right? Again, I think, yes, it is a predictive auto scaling, but still, I think what we wanted to try is like not take that recommendation blindly. Rather, we wanted to little over provision, like not say if it says like 30 doesn't mean that we wanted to go 50 or 60. Rather, like we wanted to at least like say a little more than what it says, just to be on the safer side. So we went with a prediction of like, let's go with like 5, or like, again, it also depends on like what service it is, right? Like for example, a login might have different traffic compared to like a search or like a payment. So these are like different microservices where like not everything would be participating in one point of time, right? So again, I think the scale of that service also matters. Like again, it is not that X plus 5 for all of it, rather like, oh, maybe X plus 1 for this use case and X plus 2 for then different use case.
Correct. So what I'm trying to ask
Mhm.
is, it sounds like what your system does is it's making the independent choice of would it scale up and by how much. HPA on its own is doing the same thing ish, and you're saying, hey, HPA at that time is like, I'm going to scale up by 6,000 nodes,
Mhm.
and you're like, we also want you to do 5 more. That's what I'm trying to figure out is what is the scale of the window of what you guys were testing with compared to what was real, actual, I guess, production level. You know what I mean? You're saying you're clamping it down to 5, which is fine if it's like a test where you're like, hey, would HPA have done 5 here?
Mhm.
Or are you saying that HPA is regularly going in a window of 10 to 20 and we're just letting this one do 5 total?
Yeah.
Does that make sense?
Yeah, of course. Like
Yeah.
for our experiment, we just went with like whatever was the recommendation plus like 5 nodes, just to be like, oh, because it is like we are inducing the traffic.
Of the HPA.
Yes.
Not that you're letting it choose a number from 1 to 5 total nodes. You're saying within. Okay, gotcha. Okay, I see what you're saying.
Yeah.
Okay, perfect.
Because we were inducing that traffic
Right.
manually. So that's again the real peak where what we talked about is like real, whereas like when we are doing these game days, like you have to like induce it, and it has its own latency and like traffic also. So I think that's where like it was kind of challenging to like come up with that exact baselines, but it is like definitely on a scalable one.
Your best shot, then
Mhm.
I think that's you're driving at. Just know your SLAs, know the parts of the system, maybe a system, a microservice may be responsible for just putting something on the queue. So it's not doing any CPU intensive work. So if you're scaling 5%, you also need to scale that also 5%, or maybe 3 might be okay.
Yeah, like I said, it depends on like what is the purpose of that service. Just because like they are dependent to each other, like even though like they participate in like say these launches or like these big traffic peaks, doesn't mean that everything should be scaled up at the same level. Because like each of it has its own infrastructure. Again, each of it has its own functionality. Like I said, I think knowing your system is equally important. So that's when like it would be able to come back with like to say that, okay, it gives the recommendation, but then like what I wanted to add as a buffer. So that +5 would not be the +5 for all the services. And that's what like I think we had to go over.
It's very skeptic of any of those products that Because I know my sister and you can sell it with that.
Oh, of course. Of course, yes. Yeah.
So,
Yeah, like I said, like this was like tested on our internal code and whatnot, right? So I think like I said before, like these numbers are from like what we had applied online, like what we see. So
what AI model did you use, like, to make the decision? Which AI model was the decision maker?
I think we tried like multiple, but I believe like we just went with like we wrote our custom one to train that. Yeah, because again, because just we started this as like a research a paper, but still we don't want to just be that numbers on the paper. Rather, like we wanted to also see that actual numbers in place. So it was like associated with our own cost as well. So that's why like we went in with our custom.
Do you know if there's any research going on where a service in a system of services can send hits to its upstream and downstream services, or the scalers can send hits? So if a particular service is about to scale up, it can tell its downstream the things it's going to call, hey, I'm scaling up, and be able to use that as it so that they can use that as a hit to scale up.
Prometheus has a language called PromQL, with which you can set all these things.
Okay.
Uh,
Is it working?
It's been there for years, actually.
that
I mean, I
actually
don't-
makes sense. We said it earlier on because as the destination of your log, which is Prometheus, is that whole system will know when traffic is coming, which means you have to then log intelligently that you know, some of you, I'm sure you've seen bad logging also, right? You know, hey, I am calling this, I just called this, I hate those things. Yeah.
Or from the Kafka queue, usually you have a Kafka queue. So from the Kafka queue, because Kafka is running in MSK, it's not inside the cluster. Right? So as the Kafka queue, the latency increases on the queue, you can send a message into the cluster with PromQL, like this is the right, so send the increase the pause.
And I believe like I think we should know also the critical user journey. I think that's where like, oh, because it cannot be applied to like only one microservice and like come up with that numbers. Rather like, hey, I'm passing this, or like the request come from service one goes to service two all the way up to like database. I think we should have that entire journey for us to be able to like, yes, get that all that connecting pieces together. Yep, the operational cost was, like I said, it was definitely because it started as like a research, and like, yes, it definitely moved up on that integrated pipeline. So each version to track and like upgrade test. So the complexity is just not that DQN, but then AI as an attack service, right? So we have to say like, hey, how can we sanitize our input? What can be rejected as a trusted URLs? So again, false positives, because like we kept running on the same service because like it is mocked up services. So there were like lots of false positive stories as well there. So these were like, yeah, we wanted to see like, hey, it is not giving that, or is it giving the consistent auto scaling numbers, or like it is going beyond what it is supposed to be and whatnot. I think those are like differently the pain points, only for the fact that it is because it was part of a research paper. Yeah, again, so the decision itself, like, should you really build this and whatnot, right? So I think we have to definitely take in that plus and minus, where to say like, I think that we wanted to do that economic test to say like, hey, if it is just like a 20% of like 12,500 month bill, like, yeah, it is like a 2,500 per month, which does not really fund on an engineer. Whereas like if that 20% on like a 7-figure annual bill, yes, it makes the difference. And that volume definitely makes that difference to say like, for a driving factor to say like, do you really wanted to build it or like no? Again, I think those are like driving factors for your business case as well. And again, I think the last item on the left, so that one is like the latency, the cost, and the churn. So these are also like equally the driving factor for most of it. And then the most common situation is like most of the teams like have not tried scaling on like a queue depth or a GPU utilization. At least that's what the study actually says. So we have to like probably do that first and see like, oh, because, and my thing is like we don't want to do it just for the sake of doing it, just for the fancy things, say like, hey, we have auto scaling also, right? So we have to like see if we can just try to scale our queue or like the GPU utilization, because like not all environments are the same, not all infrastructure is the same. So we wanted to do that and say like, hey, if it is just the configuration change, see if that actually addresses the failure mode that we actually opened it up, right? Like that would be a big driving factor. And again, governance. So if we cannot explain the current threshold based decisions, then I don't think any learned policy, any models would not be able to come do that magic, like because your audit or your numbers actually makes a bigger decision and or is making a driving factor for a lot of things. So that's why like it is really important to see like, do we really wanted to build this or not? Yeah, the key takeaway here, more like a summary. So like I said, we should not just be building it just for the sake of like building it. Right metric, it could be custom or like external metrics. Like it could just be a configuration change also, not being treated as like a big project on its own. Then the readiness, right? Again, I think this is more like underestimated or like underappreciated, I believe. Like say if there is a JVM pod that goes ready before like your JIT warm up or like scaling up activity, that would actually hurt your P95 for the next 20 seconds, right? So the underlying problem itself could not be the pods, but your JVM itself, like Nitish mentioned. Then your behavior block, like say, hey, we wanted to scale up fast, scale down slowly, or like that explicit a percentage policies, or the cheapest oscillation fixes like the Kubernetes, or like again, most of the time, like even the default ones would just be fine. Then the scheduled pre-scaling, I think this one is like a really highly effective, I believe. So if you know about a day and a time to encode it, I think that would also be a legitimate engineering answer, right? Like, oh, we know for sure that on a Monday morning there is going to be a batch job that is going to run, and like if that happens like every Monday morning, why not, right? So I think that one, and then the right-sized request. I think these are the key takeaways where like we wanted to see like how we can make that autoscaler like really smart and like more efficient or effective, rather than like just put in place just for like, hey, let's do that, right? So again, I think this is how like we did our experiment on the rollout order. So again, the first 2 weeks was more around instrumenting and like gating. We did try that Prometheus, but then like we wanted to also see like the how the vector itself like work on its own. And then collect and shadow, one namespace, the real control, that is where like we started to inject on a service base to say like, hey, how can we start to fail our systems, or so that like it gets ready for the failure, or like how it can operate on a failure, right? So and then promote and stop. I think these were like a different phases that we did. And yep, I think that's pretty much it. Like this is still like 3 things to remember. Like I said before on the start of the talk, like the reactor scaling is structurally late, but then like it is not bad tuned at all. Like I said, it definitely works, but then like it can definitely be better. Yeah, fix the inputs before you change that algorithm. Like I said, not for every problem you need like a brand new solution to be there. It could be as simple as like just tweaking your infrastructure, and like it would still be okay. And yeah, I think the third one is like more on the guardrails. The autoscaler would not defend in the incident review, but you should run on it. And yep, I think that's pretty much